Howdy. Thanks, Tom. Welcome to Slacker app. We made a resource-finding web app with Slack chat integration for Code Platoon students. I'm Jack Schuff. I'm an Army veteran, and I worked on the bot and the database.
My name is Steven Sun. I'm an Air Force veteran. I work on the front-end side of our app.
Hi, I'm Jonas Polakis. I'm a Navy veteran, and I worked on the bot, database content, and some of the design components.
Hi, I'm Mark Stanley. I'm an Air Force vet, and I worked on our Firebase implementation and React components.
Hi, my name is James White. I'm an Army veteran. I worked primarily on the front end and design components of the web app, and I'll also be presenting the app overview. So when we first came together as a group, the project that we now call Slacker was little more than a relatively jumbled bag of ideas that all swirl around two unifying characteristics. First, Code Platoon was and is an incredible program. Second, Code Platoon was an incredible challenge that we'd all managed to overcome. With these two things in mind, we knew that we wanted to make something to support the learning experience of future students and the program as a whole. We recognized that a large degree of the challenge that stemmed from the course was simply innate to the content. The phrase drinking water from a fire hose was thrown around very often to describe the pace. No matter how you slice it, we learn a lot in the 14 weeks we were here, and that's never going to be an easy task. That being said, we also collectively identified another key area of discomfort in the often laborious and time-intensive pursuit of reference and troubleshooting material. To address this problem, we created Slacker, a one-stop shop for Code Platoon students and instructors to both store and access key reference material. Our design philosophy revolved around the premise of reducing overall time spent searching for relevant documentation and potential bug fixes in order to increase the amount of time students spent actually coding. Additionally, we wanted to make answers to common questions students may have publicly accessible and visible, rather than relying on students scrolling through pages of past answered questions. In order to do this, we decided to implement two core features: a web app that would serve as a base of operations where students could search a curated database of references and solutions to common problems, and a Slack bot, which allows for students to query this reference material without even needing to leave Slack. And with that, I'm going to hand it over to Mark to demo our application.
Thanks, James. Now let's see how Slacker's web app component works. We're already logged in as an instructor from a previous session. Utilizing Firebase authentication meant we could spend less time making sure user state worked properly and more time on our core features. On the homepage, Slacker displays a search box for querying the resource collection, several curated resources for the Code Platoon tech stack, a daily cohort sentiment graph scraped by our bot component using IBM Watson's natural language understanding engine, and a motivational quote just in case you need some inspiration. As an instructor, we're here to add a new resource that recently helped solve a tech issue for several students. So let's navigate to the resources page to quickly update our collection. Adding new resources is simple. We provide a title, a summary of the content, the category, tags, and the third-party URL to direct the user to. Our Firestore database collection is indexed by Algolia Search API and synced to monitor real-time changes. Now that we've added a new resource, let's switch to the student point of view and search for it on the homepage. Algolia allows us to provide custom search ranking to our index fields to ensure students get the most relevant results to their query. It looks like we found the resource the instructor just made, and after clicking the title, we're directed to the page that hopefully solves our Django cores issue. The other component to our website is our code page. Here we have content tabbed by Python, JavaScript, Markdown, HTML, CSS, and SQL. Users can add code examples using an in-browser editor that not only offers language-specific syntax highlighting, but also language-aware indentation, code folding, auto-completion, and commenting. I'm curious about dates in Python, so let's see what someone submitted. In this detail view, the editor is read-only, but allows the user to highlight and copy text. Updating something is simple too, like this typo that we just caught. So let's fix that really fast, and then we'll pass it off to Jonas to talk about the bot component of Slacker.
Thanks, Mark. Slacker, the operator bot, was constructed as a Google Cloud function-based bot that interfaces with Slack event and web client APIs, as well as Algolia and IBM Watson natural language understanding for sentiment analysis. Among the bot features, it can invite me, a new user, to its channel, as well as provide commands for how to utilize the bot. And I can provide the operator bot a query, at which point the bot will attempt to match the query with an existing link in a database. And along with that, a link to the main database will always be provided just in case the provided information happens to not answer my question. Now, moving along, let's just say that I'm working diligently and, why not? I need some comic relief. Not a problem. Slacker can be prompted to deliver a humorous attempt at a pun, in other words, a dad joke. But what if the dad joke happens to fall flat and is, quite frankly, a bad joke? And I would like something else to lift me up. Okay, not a problem. Slacker can be prompted to deliver an insightful and motivational quote, and now hopefully I'll feel better and be ready to get back at it. And with that, I'm going to turn it over to Stephen to talk about stretch goals.
Thank you, Jonas. As part of our stretch goal, there are features we want to implement in the future. We want a way to diversify our current resource page, which is currently only accessible by the instructors. One feature would be to allow the students to submit their own sources. In addition, we would like to add the ability to rate those sources as well. By allowing students to rate the sources, we are able to monitor which content is useful for students, as well as improving the overall quality of the resource page. Finally, our most ambitious stretch goal is to improve on our current Slacker bot to make it more dynamic. What this means is instructors will be able to type in a simple command in a Slack channel to view a particular channel's sentiment using IBM Watson's natural learning language. With that, I'll pass it over to Jack for the tech side.
Thanks, Stephen. For our technologies, we used React and Bootstrap on the front end for styling and rendering of our components. The logic was mostly written in JavaScript, and we used Algolia and Firestore's NoSQL database to store, archive, and search our resources. We used the Slack web and event APIs, along with Algolia and Watson natural language understanding in order to provide the sentiment analysis and receive and send data between Slack and our database. On the workflow, we used a Trello Kanban board where we laid out the tasks that we had to do and the sequence that they had to proceed in. We needed to have a database before we could have a bot pull resources from the database to render into Slack. We used our daily stand-up meeting every day to ensure that the necessary functionality that we needed for next week was coming online this week. Some of the challenges we experienced with this, in particular, the two that stand out to me are the roles and authentication to ensure that instructors and students had a different view on the web page, as well as integrating the variety of bot APIs that we used on the Slack side to make sure that the data flowed between our database and over into the sentiment analysis as needed. Also, of course, the dreaded merge conflicts. We are novices, but we learned quite a bit by the end of about day 3. Basically, our merge nightmare was over. The last one was synchronizing our efforts in a remote setting. We're all over the place. I'm in Pennsylvania. We have folks in Chicago, and we managed to use our daily meetings as well as just checking in on Zoom and Slack to stay abreast of what is happening over on the stylized efforts or in the design efforts in the back end. In closing, I want to say that our daily stand-up really did us a lot of favors in our parallel effort here. We were simultaneously stylizing, designing, and building different components, and it ended up working very well due to the fact that we had a really solid organization in our Kanban board. It was a tremendous effort from this team, and it was a pleasure to work with Team Slackers to accomplish this. I appreciate everything you guys have done, and if you'd like, feel free to have a look at our website at operator-slackbot.web.app, and I am happy to receive any questions.
Awesome. Thank you, Slacker team. So why did you decide to use the Algolia API, and what benefit did that have over just, storing things in, this Postgres database and just doing like a live search from there?
Mark, would you like to take this, or shall I?
Yeah, I can take that. Once we started to really understand the objective of our app, we started to realize that we needed a scalable database that didn't necessarily have any kind of relational context to the different sources. So using the Cloud Firestore database made a lot of sense because you organize documents in a collection, and each resource is a document in a collection. How we conceptualize that. And luckily enough, Algolia is kind of a built-in extension of the Cloud Firestore database. And so that was kind of a natural progression for us in order to be able to index the database that way and search, the different fields in each document as a result.
Awesome. Continuation on the Algolia API. So how did you define the boost rankings of the resources in Algolia? Like, how did you determine which resource was more valuable to the user than another?
Our initial read was that we would end up having to modify how Algolia ingested the data so that we could get the proper results. But what we found was due to the curation that we had done in the backend side on the resources, the data there tended to sort itself, and your query would almost always find the intended article just based off the fact that it hit the majority of the keywords. So we honestly did not modify the baseline Algolia functionality. We didn't turn the dials up on any of the various fields that we were sending into Algolia to modify the query results.
Awesome. And last question, can you talk about in more detail how the web app and the Slack integration works? Was there something special you had to do to add a plugin to Slack and have it interact with your app?
Yeah, so building a Slack app, you use the Slack API libraries, and you have two sets of them. One is the event handler, which will send a particularly formatted packet to an endpoint that you define. And then the other is where you send data with authentication into Slack, where it can then post messages on your behalf or invite users to a channel as needed. So what we had to do is we use the Google Cloud functions, which are they're like an AWS Lambda like serverless function. So that anytime a packet would hit a certain endpoint within our Cloud Functions address, we would then fire off some JavaScript logic to post messages in the Slack, or to invite a user to a channel, or to pull a resource out of the DB and pass it in a specially formatted Slack message using their block builder. I'm happy to explain any more of those details if you'd like.